Okay. Today we're going to look at ranges and domains, and it's a pretty straightforward section. It's just that it's got you have to go back and pull up some of your interval notations from chapter 3 that we had, because it asks you to do some interval notations, and it also asks you to do some set stuff. So if I have two parentheses, that means the stuff on either end of this is not included. Remember that? Then, if I have a bracket and a parenthesis, that means one piece is included, and the other, the other is open. So what this means is it's going from 4 all the way up to positive infinity. The other is that you have a parenthesis and a bracket, and that one's usually a negative infinity to 2, meaning that I include the 2, but I don't know where infinity ends, and so I have that piece at the tail end. And then the last one is a bracket to a bracket, and that's usually 4 to 7, and that's saying it only consists of between 4 and 7. Okay? As my pieces to those. So we have these type of things in there because as we start talking about interval notation, we've got our sections, not intervals, but our domains and ranges. We have different pieces in there. So in definitions, we have so far been graphing straight lines, and the straight lines we've been graphing have had, of course, a slope to them. What kind of slope is that one? What kind of slope does that have? Positive slope, because it's going from here and it's going uphill. So it's a positive slope, so it's heading in that direction. So we got positive slope happening with that one. And on this, we have x values we plug in for that line, and we have y values. And our points, remember, we're always in the format of 2, 5. 2 meaning x's, 5 meaning y's. Okay? And we said 2 was independent, meaning that if I'm out at 2 and I'm up at 5, I end up plotting a point on that line, and so it's the relationships that I happen to have that end up giving me that. Well, in domains and ranges, a domain is equal to the x values. So the domain is on or in relation to the x-axis. So stuff with the x-axis. So my domain on this is always going to be stuff along the x-axis. So if I'm walking along the x-axis and I keep finding values along the x-axis that end up representing the stuff on that line, I know that that line is going to go on continuously and it never ends. So it goes on indefinitely in each direction that I happen to have in that. Okay? Then range is the y values. And so if I look at my range, the range is on the x or y-axis or in relation to the y-axis. So if x is domains, y is range, I have two things that affect my line. My line's affected by its range, which is going up and down here. And if I look at my range and I go about and check my range, every time I go out on my range, I keep finding a point that's related to it. Does that make sense? Yes? No? Okay. So then, if I'm given just plain points, if I'm given 2, 4, 8, 7, 3, 6, and -1, 5, just the values of points in here, what are my domain values? So the domain values are all my x's. and you list them because it's not a solid line. These are just dots if I put them on my graph. So if I had my graph out here and I graph 2, 4, I would be up and have a 2, 4. Then I'd be out at 8. And I would be up at 7. And they're just simply dots. When I'm at 3, I'm up at 6. When I'm at a -1, I'm up at 5. And they're just dots sitting on there. So my domain has to be listed as a set. So if I list it as a set, my domain is 2, 8, 3, -1. Now that's not in order. So if I went and I put this in order, it would be -1, 2, 3, 8. Okay?
And how are you going to have to put it in like
I don't think they make you put it in order. I think you just put it in. Do they? They do? Okay, they do make you put it in order. I was thinking they didn't, but they do. Yep, so make sure you put it in order. Did it? However you wanted it and accepted it? Okay, so I guess you can just bounce back and forth with it. So you can do it different ways. What's my range?
So your range
It's going to be all your Y's.
4,
So it's 4,
7,
7, 6,
and 5.
and 5. Okay?
4, 5, 6, 7.
Yep, and if it's in order, would be those. Okay? Now, we use set notation for these because you're looking at what creates that set and what values are holding those X positions and those X values
You
in
have
there.
to use those little parentheses things too.
The braces?
The braces.
Yes.
Yeah. Well,
You need to use braces in here, so make sure you're careful with that and use braces whenever you're given certain point values that you're looking at.
For domain and range?
Domain, and if you're given a point, if you're given just plain straight points. So straight points, use braces. So you're going to use braces with that. Now, in these domains and ranges, not always do you have everything that's separate. So if you were given these points, 2, 4, 3, 8, 2, 9, and 2, 5, what would be my domain? Well, my domain is just a combination of 2 and 3 because these 2's are duplicates. Okay? But my range is going to have 4, 5, 8, and 9 in it because I've got all of those associated with these values that I have up above. Okay? So then what you start looking at is saying, is this a function? And it is a function if all x's, or the domains, have only one y associated with them. So only one y associated with them. So is the example I gave you up here, is this a function? That's not a function. Okay? Okay. It is a function, and it's a function if all x's meaning x values here, all these x's only have one y. Notice this 2 has 4, it's fine there, right? But when I go down here, this 3 only has 1 8, perfect so far. But 2's being a little funky here because 2 has a 9 associated with it now. And 2 also has a 5 associated with it. So what that means is it's not a function because these 2's are all shared. So then if we take that and if I looked at it on a graph, what would happen is when I'm at 2, I'm up at 4. When I'm at 3, I'm up at 8. I'm fine there. But when I'm at 2, I'm up here at 9. So right above 2, there's another one. And when I'm at 2, I'm at 5.
I can do it that way if you graph it.
Mm-hmm.
I just can't do it by looking at it.
Yep. If you graph it, then what happens? Notice all these 2's are right on top of each other. And so they're right above each other, so therefore it's not a function. Okay? The other thing that makes it not a function is, notice I have fewer domains than I have ranges. Notice there's fewer domains, there's only 2 domains compared to 4 ranges. That right there is telling me I don't have a function.
So they're
Okay, because
equal.
they're somewhere shared. If they're equal, it's a function.
What about when they do it the opposite way and you have to actually look at what they already plotted on the...
Yep, we're going to go there in a minute.
Okay, because that's how I
Yep.
always determine it.
Yep, we'll go there in a minute. Yep. And then what they say is that you do what's called a vertical line test.
Yeah, that's what I...
That's what I was thinking of.
And when you do a vertical line test, what that means is if I ran a vertical piece of paper along here, and everywhere I go, I only touched 1 dot, but as soon as I get right here, what do I get? I get 3 dots right in a row, don't I? And because I get 3 dots right in a row, right in here, that means that I don't have a function. Okay? If I had another graph, and I have a dot here, and a dot here, and a dot there, and a dot right there, is that a function? I don't even have to know where they're at, do I? Because as I run my vertical line along here, I touch 1 here, I touch 1 there, I touch 1 here, and I touch 1 there, so this one is a function. Because I don't have more than 1 shared. Okay? It's kind of like if a man is dating 2 women, is that functioning very well? Kind of the same thing, because if it's an X, it's kind of like up here. This X is dating 3 Y's. Okay, not good. Okay, not a good relationship. Okay, not a good function. Or a woman is dating 3 men. Is that functional?
A man dating 3 men.
No, a woman dating 3 men.
That's even worse.
That's even worse? Oh, well, not a function. Okay, so always keep that in mind, that every X can only have 1 Y. Okay? And so when you get that part going, that happens. Now, they do consider this to be a function, though. 2, 5, 3, 5, 9, 6. They consider that a function because every X has only 1 Y, right?
So
This one's got 1 Y, this one's got 1 Y, and this one's got 1 Y. But if you look at that, what happens? Y is kind of doing a double thing there, right? When you get into intermediate algebra, we don't let that happen anymore either. But right now we do. So you can have the same thing in there, but you can't have the other part going on. Okay? So X can only be connected with 1 variable. Okay? So always keep that in mind, that you only have 1 variable connected in there with those. And so that's what you have a point. But what happens when you get some graphs of stuff? So I've written some down here. And we can look at these and see what happens to our domains and our ranges on them. If I've got a straight line, what do you notice on that straight line? Is it a function? Yes. So yes, it is a function. But is it, what's its domain? Well, the domain is all the x's it can possibly be. So when I look at a graph, what do I know? Well, everywhere that I go up on this, I run across an x, right? Do you see that? So everywhere I go, I've got an x somewhere in there. So what does that mean about my domain? Well, my domain in this case is from negative infinity to positive infinity. You okay with that part? Okay. Now what do I notice when I go back and I look at my y's? So here's y. So everywhere I walk across, because this keeps going down here, this gets extended. And it goes extended. So everywhere, that pencil's not drawing very well. Everywhere on here, I hit a y value too, don't I? Do you see that? So what does that mean? If I hit a y everywhere, what does it mean about my range?
that's a 90 degree
My range is also going to be from negative infinity to positive infinity because it goes on and on indefinitely, right?
Correct.
Okay. Now if I go over to this line stops. It ends here and it ends here.
It is a function.
So is it a function?
Yes.
If I do my vertical line test, I touch there, I touch here, I touch here. Notice I'm not getting double things that I'm touching in it. So it is a function. But what's its domain? Well, if I'm on X and I'm over here and I go down, I don't hit anything, do I? If I keep going in this spot, I hit nothing. I start hitting something right here. So what does that mean? Well, that means my range, or my domain, is going to go from here, and you keep hitting something there and there and there and there and there, and I get right to here, and then I don't hit anything after that. Do you see that? I don't hit anything out in this area. So what's my range? Well, my range is only going to go from -3 to 1, 2, 3, 4, 5. And so my domain is limited, but it does include a -3 and it does include 5. We okay with that part? What do you think? Yes?
Yes.
Okay. What's its range? Now range is Y's, okay? So I'm walking along here, I don't see anything, I don't find anything, until I get right here. Okay? And that you said was a -1. And I keep going and going and going and going and hitting and hitting and hitting, and then I get here and I hit, but then I don't hit anything up here. So it stops right there at what? 1, 2, 3, 4, 5. And because they are included, because there's points on them or dots on them, I put brackets around those. Okay? Make sense?
See, like Hawks, that's what I was wondering about, the brackets and the parentheses, because Hawks, like, I don't know, it should have accepted, or it shouldn't have accepted some of the answers I put in, if that's the case, and it accepted them.
Okay.
Because, like, as I was sitting there working on it or whatever,
Okay. Yeah.
I don't know.
Okay. Yeah, because you should get your brackets because these end at that point. Okay? Yep.
That was what I was told because of the dots, but then,
I don't know either, Amy.
do you do like a bracket and a parenthesis?
Yes, if it goes on, it can go on indefinitely in some direction. You could. Yep. Yep. So what if we look at this next one? Is it a function? Function meaning that X is associated with only one Y. So if I check my vertical line test, it's only touching a single X with a single Y, right? So it is a function. What's its domain going to be? Well, it's got arrows on here, and what that means is it keeps going this way and it keeps going this way. So is there a limit on my domain? Infinity. From negative infinity to positive infinity. What about my range? Am I limited there?
Yeah.
I go here and here, nothing, 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 nothing. Oops, I hit something right there, right?
Oh, okay.
And then I keep going and going and going and going, and it never ever ends on that end. So this is your combination, Amy, of saying does it have a bracket and a parenthesis? Yeah. Because in this case it stops right at a -2. It's where it starts. It goes all the way up to a positive infinity. So it's a bracket and a parenthesis.
Okay. Here we go again. Alright, how do you figure out the bracket?
Okay, it's a parenthesis. It's a parenthesis because it's got arrows on the end of the parabola, meaning that it's going to go on forever and ever.
No. That part's understandable.
Okay.
I'm talking about how do you place your brackets and parentheses?
Okay.
How do you know what goes
Bracket means it's included and it stops there. It's like hitting a brick wall. It stops there. It starts right here. It's hit a brick wall because it can't go below it. So the brick wall means I need a bracket. Okay? Because it's going to infinity, I don't know where infinity ends, so it's a parenthesis. Yep.
So anytime you have infinity, it's parentheses.
Yes.
Anytime you have it stop,
It's a bracket. Yep. What about this one next to it?
What happens if it's a triple?
We're going to go there in a minute. Just give me a minute. What's this guy going to do? Is it a function?
Yes.
Yes. Okay, it's a function. Where's its domain start? So I'm going along here, and I get right here is where I get my first one. So that's at 1, 2, 3, 4, negative 4. And I keep going, and I go, and I go, and I go, and I go, and I get to here, but then I go beyond it, and I don't get anything. So where does it end?
Move it down a little bit.
Yep, where does it end? 1, 2, 3, 4, 5. And are they included?
Wouldn't it end at the second dot?
Here?
No. Up.
There?
Yeah.
Yes, but that's coming down here at 5.
Oh.
Okay? Because you're looking at your x values for it. Where is x in relationship to this point? So that point's at 1, 2, 3, 4, 5, comma, 1, 2, 3, 4, 5, 6, 7. So its location is 5, comma 7. So it's at 5 for my domain. Do I put parentheses or brackets?
Brackets.
Because
It ends.
it ends.
Since it talks, the way you know that, those are all
Okay, they might be. I'm just doing a different example in here. Yep. Yep. Because they both end up coming and closing at that point. What's its range going to be? So I'm walking along here and nothing, nothing, nothing till I get here. That's where I've hit my first thing I noticed. So it's at a negative 2. Keep going. Cut there. Touch, 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 touch till I get here. And then beyond that I don't hit anything. So it's 7. And because there's dots at the end, they're included. And so that would be my answer to that one. Okay? Now, if this would have had a continuation on it with arrows, how would that change things?
It would not be.
Then my domain would be infinity, negative infinity to positive infinity, because it never ends. And my range would be also negative infinity to positive infinity. So arrows mean it goes on indefinitely. Okay? Yep. All right. What if we took a look at these guys? Vertical line test. Is this a function?
Yep.
Yep. Okay. So it is a function. What's its domain? But it means this goes on here and this goes on there.
Positive, negative, infinity, negative.
Yep, from negative infinity to positive infinity because it never ends. What about its range? Range is it's going to go this way out forever into negative infinity, but what happens when I get way up here? I don't find anybody else up in this area, do I? So my range is from negative infinity to 2. Okay? Brackets or parentheses? A bracket on the end, parenthesis in the beginning. Is this a function?
No.
No, because I hit 2 spots in there. We don't have a relation going on right there. It's not correct. Okay? So this is no, not a function. What about its domain? What would its domain be? Well, I'm walking along X, nothing in here until I hit right there, right? And then I keep going this way, and it keeps going on forever and ever. So its domain is negative 2 to infinity. Stops at a negative 2, so I have to include it with a bracket. Range? What's the range going to be? Remember, it's going to keep going. It goes way out here, and it goes way out there. Yep, negative infinity to positive infinity. Yep. What about this one? Function or not a function?
Not a function.
No. Okay, not a function. What is its domain?
This one.
And because there's nothing else but a negative 3 to it, it's inside of braces. And its range?
Negative infinity to positive.
Yep. And what about that one? Is that a function?
Yeah.
Yep, because every x has one y, but its domain?
Positive infinity.
And its range? What's its range?
Negative.
Mm-hmm.
It's negative.
With braces. Mm-hmm. Because there's only a -3 to it. Okay. Alright, yes? Then the circles. Finally, we're getting to where we're talking about something that you asked about. If you've got a circle, is it a function?
No.
If I do my vertical line test, it's touching in certain spots, so it is not a function. But what is its domain? What would its domain be? From a -4 to 0, because it stops right there. And what's its range?
From -2 to 3.
Yep. With brackets around it. Okay? Makes sense? On a circle? Think so? Okay. And ellipse is the other one. Is it a function?
No.
No. And its domain? In other words, it's what can I pick for x's to make this thing work. So I can pick from here to here. -4 to 2. Yes. Range? From 1 to 5? Yep. And that would be your answer. Okay? And Hawks will give you pictures just like this. It'll ask you if it's a function, and you have to determine. It'll ask you what your domain and what your ranges happen to be from within that. So, okay, what do you think? We good with that one?
We're good.
Okay. So we got a little bit left of 9.5 to go. So we got a little bit left of 9.5 to go. And that is where they give you a function and they ask you to plug in a value for it. Such as if they gave you the function of h when it's at 5, and they give you h of x is equal to x squared plus 4x minus 3. And if we have to solve that, what this basically means is where I've got a 5, I'm going to take that 5 and I'm going to replace every x that I happen to have in there with a 5. So 5 squared plus 4 times 5 minus 3. So what's 5 squared? 25. 4 times 5 is 20. So 25 plus 20 minus 3. My value would end up being
38. That might have a
25 plus 20 is 45. Take away 3 is 42. So I'd end up with 42 for an answer. And that's what is happening when the value of x is equal to 5. So you're basically just plugging that piece back in. Another one might be f of x equals 2x plus 5. And they give you when x is a. What would my answer be if x were a? So now all I do is replace x with a, and I end up with the answer of 2a plus 5. And that's what it ended up equaling. Yes?
That problem that I just showed you,
Mhm.
when you have to find the domain and they give you the point slope,
Mm-hmm.
they only give me one of those.
Did they?
Yeah.
Yeah. They kind of slipped some ones in there. You may have only had one, but somebody else might get 3 of them. Just depends. I know. It's kind of not the good thing to have happen that they plug some of those things in there and come up with them. Another that they give you, maybe y equals 1/2 x plus 2. And they say, what's the domain? Well, the domain of this one, because what kind of line, what kind of graph would I get? Excuse me, out of that. What kind of graph would I get if I graph that? It's my usual, my slope-intercept form, so it's going to be a straight line, and I'm going to go up 1 and over 2, and I get a straight line. What do we know about straight lines and domains?
They go on forever, so
forever and ever and ever.
Domain and root.
And so my domain
All real
is really
numbers.
going to be all real numbers, or from a negative infinity to a positive infinity, or all real numbers.
They'll take either one though, Hawks.
Yes.
They'll take
Mhm.
either one.
Yep. Yep, they will take either one. But it'll be either all real numbers or just your set values that you have in there. Yes?
Is there another way? This is the way I did it that way, but couldn't you, since X and Y are both just open variables?
Uh-huh. Yep.
Can you still do that
That
way?
also is giving you, yes, that's giving you the option of putting in any value you want for X and kicking out whatever value the Y is associated with that value for X. Mm-hmm. Yep.
As long as one input has.
Yes. Mhm. Yep. Yep. Mhm. And in most cases, in Hawks, they're giving you lines. They'll give you a line and ask you what its domain is. They're not going to give you anything else to graph in this format besides those. Another one that I have seen pop up in Hawks is where they give you f of x equals 3x minus 4, and they tell you that they're going to replace x with a minus 3. And when you do this one, it's going to be 3 times a minus 3 minus 4. 3 times a, then you got to distribute. 3 times negative 3 is a negative 9, and then combine your like pieces. Negative 9 and a negative 4 is a negative 13, so I get 3a minus 13 would end up being my answer for that one. Okay? So that's what happens with that. So if you got to substitute some stuff in, that's what you end up doing, is replacing x with it. And so that was the other piece that pops up in your homework sections in Hawks with that one. Okay, now we're ready for the very last section of Chapter 4. 4.6, and in 4.6 it's graphing inequalities. And inequalities mean greater than, less than, greater than or equal to, greater than, less than or equal to, and less than. Those are our basic inequalities that we can happen to have with these. And when we graph these, the equals means that the line is included. So if you have a less than or equal to or a greater than or equal to, the line is included and the line is solid. Now the reason I say that is because Hawks will give you an equation of a line to graph, and it will ask you whether your line is solid or dotted. If it is a less than and greater than, less than or greater than, the line is dashed or not solid because it is not a solution to the graph. So it's going to be a dashed line, so it won't be a solid line. And this will make more sense when we start looking at graphing these things and coming up with what they start looking like. So if you're given an equation such as, well, before I do that, I guess I should tell you what sides get shaded in these. If you have a greater than or equal to or a greater than, the top of the line is the shaded part.
See, this is what my instructor didn't teach me in the last class, and this is why I got confused with the shading. So I knew there was a certain pattern that you could shade, and he just kind of made us go through.
Yep. Or use a checkpoint to find it.
Okay. This
You can do
make
it two
one
ways.
equal.
If it is less than or equal to or less than
Bottom
the
shade.
bottom of the line is shaded. Or use a test point to find it. So if you can't remember which one's which, you can always use a test point, and we'll talk about what I mean by a test point with this one as we work through that. So if I were to graph one of these, I'm going to turn my paper over. You guys done writing? Still writing? Some people are, I think. Move it up a little bit so that you get caught back up on writing. Grab a sheet of graph paper over here. It's a little bit easier. Okay, I'm going to flip it. Ready? Okay. Get that one out of there. If this were my equation, y is less than or equal to 2x plus 4. So what I would end up doing with this is I would end up, of course, graphing my line. I get this dark enough in here. And if I graph it, what would I have to do? What does it tell me to do? So back to my y, if I just had y equals 2x plus 4, what would I do to graph that? Up 4, 1, 2, 3, 4, and up 2 and over 1, okay? And so then what would I end up doing? Because there's an equals, I will put a solid line through this thing. So it's going to be a solid line. Okay. It may ask you in Hawks to find 2 points. Did I find 2 points by doing what I just did on my graph?
Yeah.
What did I find? I found the y-intercept, which is 0, 4. And I found a second point when I rose 2 and ran 1, because that gave me another point of 1, up 1, 2, 3, 4, 5, 6, and I've got 2 points. Yes?
So if in greater than or less than sign is a dotted line and an equal sign is a solid line?
Yes.
Okay.
Yep. If in your inequality you've got a equal sign right here, then my line is solid.
Okay.
Yep. If I don't have an equal sign in there, then it's dashed.
Okay.
It'll be a dotted line. And as soon as you click in Hawks, it'll say solid line or dashed. And it'll say which one you have in here. So if it's a solid line, you'll click on solid line and it'll put a box in there, and so it knows when you find your points that it's going to put a solid line in your equation. Okay? And it'll automatically do that part. Okay, now I got to determine what side gets shaded. Well, if you followed my rules, it says shade above the line or below the line. Well, which is above the line? Well, if you're confused and don't know, this is considered to be above the line right here. But if you don't know that, pick a test point. Your easiest test point is 0, 0. Because what I'm going to do with that test point is I'm going to plug it in here. So 0 is less than or equal to 2 times 0 plus 4. What's 2 times 0? 0. 0 plus 4 is 4. And if my statement comes out to be true, I shaded the wrong side here, sorry about that. If my test point comes out to be true, then 0 is less than 4. I want to shade where 0, 0 is at. So I had the wrong side shaded because I should have shaded below the line because it was a less than. I wasn't paying close enough attention to that. So this side wasn't shaded. This side is where it does get shaded at for that one. So let's do another one of these. See what we can come up with for that one. Y is greater than
So in other words, just
2x minus 6. Pardon?
or what?
Yeah, you're better off probably doing a test point.
I thought that was-
Then you'll know what one you got going. Yep. Okay, so is this going to be a solid line or dashed? It's going to be dashed because there is no equals. That's probably the easiest piece of your whole problem to figure out. Then it says find 2 points. But if I look at this and I find 2 points, my easiest way to find 2 points is to look at what I have. So I know I have an intercept. Use it to my advantage. So that means I'm going to be down 6. So I'm down 6. What's my slope tell me to do? We're up 2 over 1. And my line is dashed because it's not included. And where am I going to shade? Greater than is above the line, but let's double check it and make sure, because here's my test point. And on Hawks it'll say A or B. It'll ask you to pick what side gets shaded, and as soon as you pick what side, it'll automatically shade it for you. And so what side is going to get shaded? Here's my test point. 0 is greater than 2 times 0 minus 6. 2 times 0 is 0, so is 0 greater than a negative 6? Is that true or not true? Yes or no? It is true. So this is the side that gets shaded, so I would pick A.
I still don't get that, Marcel.
What?
I still don't get that, even the test point.
Okay.
Is greater than, okay, I understand that's true. But how is that telling me what side to shade?
Where it's at. 0, 0 is right here.
Yeah,
So if this is true,
yeah.
I will shade where 0, 0 is at. I'll shade that side where it's at. It's right here on this side of the line. So I'm going to shade where it's the side that it's on, and this is the side it's on. Okay?
Here's in the middle.
I know, but here's my line.
I've had problems with this last.
Okay, here's my line. Right here's my line.
Yeah.
Got my line right there. Okay? And since this is my line, it's breaking this into 2 parts. This line goes on up here and down there. So what it has done is it's taken this graph that I have and broke it in 2 pieces. This line shatters it or breaks it right down the center to this side and to this side. So you have 2 separate sides to it. And because I have 2 separate sides, 0, 0 lays on this side of the line, correct? You agree?
Yeah.
Okay? It doesn't lay on this side of the line, so therefore if it lays on this side of the line, if it's true, then I shade where it's at.
That makes sense.
That make sense?
If the line was up, it would be, gotcha.
Right.
I've always had problems with this
Yep.
for some reason. I don't know why.
Yep, but that's the side you'd end up shading with it. And so I would pick side A, because it's going to ask me, but I need another point in here, and my other point was 1 comma negative 4. And I need to put that other point in. It will not put this point in until you put it into here. Okay? But we find it by plotting or going to your graph, seeing where that's at, and then going up to and over 1 and finding your separate point in there for those. Or you can go and put this into your calculator and find in your chart and your graph there, or your table, and find it that way too. But we are going to end up picking side A, and so I pick side A, and I come up with my answer. So let's do another one of these. That's in standard? Sure. If it's in standard form meaning that I don't have y all by itself, and I have something that I don't have a straight strand. Oh, here's one. I have 5x plus 6y is less than 30. So it's not in my slope-intercept form. Everybody knows that? Because y is not by itself? Okay. So since it's not, how do I get it by itself? Well, I've got a minus 5x. I don't have to flip any because not dividing by negative, but if that were negative, then I'd have to flip signs. Okay. Divide by every piece by 6. So I have y is less than a negative 5, 6x. 30 divided by 6 is plus 5. Okay. So now, if I take that and I graph it, what's that going to look like? Well, here's my line. So I'm going to be up at 5.
So your negative 5/6 is slope.
Mm-hmm.
Okay, we're still doing MX plus B.
Yep. That's in the form of MX plus B.
Yeah.
Yes, because that helps me graph it. So one of my points is 0, 5. What's another one? It says down 5 and over 6.
Then it really doesn't matter, as long as it's down 5 over 6, down 5 over 6.
Yep. And so what's the second point? Mm-hmm. Is the line solid or dashed? Mm-hmm. Okay. Above the line or below the line?
Do the test point again.
Okay.
Please.
Okay. It would be, if I were just doing above the line and below the line, it would be below the line. Here's my test point of 0, 0. Notice it's to the lower part of the graph. And if this were part A and this is part B, what side do I shade? So plug it in. 0 is less than a negative 5, 6 times 0 plus 5. So is 0 less than 5?
Correct.
True or false? True. So I shade below my line for my answer. If this came out false, then I would shade where B is at. Okay? Yeah. Okay. Let's do another one.
Oh, and it's 13,
13x.
12, yeah.
13x plus 12.
Yeah. This is less than, right?
Is the arrow pointing towards this or away from it?
Point forward.
Yep, that's less than.
Okay, less than a negative 13y plus 12.
Okay.
And I know that it's going to be dashed.
Yep. We don't have to do any math to know it's dashed because there's that value in there. So it's dashed. Okay. Solve it for y.
Even if it's on that side,
Mm-hmm. Gonna minus 12. Minus 12 is gone. And then what I'm gonna do?
so now it's just 13x minus 13x is divide less than x.
Divide by negative 13. 13 divided by negative 13 is a negative 1. But because I divided by a negative, what has to happen to that sign?
Plus going to be flipped.
Equals y. There's less or is greater than y.
Can you flip it back over?
Yup.
Put
You
Y.
can put y, keep your point. Keep your point. So what's this thing graph as?
It's going to be a straight line. That's a negative 1.
Nope, because it's got an x and a y. It won't be a straight line. It'll be a line, but 0, 0 because there is no intercept. 0, 0 is my starting point. Then I want to go down 1 and over 1. Dashed, we said.
Can you tell by the greater than and less than which side it's going to be? Like that's pointing that way, so would it be under 1?
Kind of. Yeah.
Or no?
Yep. Yeah, you can.
Kind of. I don't like
Well, you
that.
gotta be careful because your graph, your line sometimes changes. It goes this way. So below the line's down here. This one below the line's here. Okay. So you just gotta be watching where the stuff's at. So can I use my same test point?
Sure.
I can't because 0, 0 is on my line. So I can't use it. So I need to find another test point. The next easiest one to use is 1, 1. So is 1 less than a negative 1 times 1? So is 1 less than a negative 1? True or false?
False.
Yep. And since it's false, I do not want to shade where that's at. I want to shade below. They're the opposite side. Okay? And then again it will label this as A and B, so you would pick side A to shade. Yes or no?
The shading part is still getting us.
Yeah.
The shading part?
Yeah.
Okay. Here's my point. You got your test point, right? You understood that part? because here's my test point.
I get.
And because I put 1 back in where y is at, and I put 1 in where x, I got a false statement. 1 is not less than a negative 1. So again, I do not want to shade where that's at. I want to shade over here. The other thing about points where you're shading is they make the whole thing true. Because if I pick this point, for instance, plug it back into my original equation, maybe this will help you out, because everything on this side will make this to be true. Whoops, this to be true. And so if I take this point, its location is -2, 1, or 1. Plug it into this equation. 13 times a -2 plus 12 is less than a -13 times 1 plus 12. And it makes it true. That's why I'm picking out this side to shade, because if I put points from this side where it's false into this, it'll make it false. So I'm trying to find stuff that makes it work. So -2 times 13 is a -26. 1 times -13 is -13. -13 plus 12 is a -1. 26 take away 12 is a -14. And sure enough, a -14 is less than a -1. So I know I've shaded the correct side. Okay? That's another way to look at it, is that you pick something within this shaded part and see if it makes it true. And if it makes it work for that one. Okay? Let's do another one. How about this one? 5x plus 13 is less than a -5y plus 13. Kind of like the last one we did. Maybe we don't want to do that one because it's going to be the same type of situation that we're going to come up with. Well, we'll still finish it. So, I get a -13. Oh, what kind of line is it going to be?
Dash.
Uh-huh. Yep, it's going to be dash line. So I get 5x is less than a -5y. Divide by -5. And I get a -1 in front of x. Flip my sign. Two points that are on it, because there is no, the intercept, there isn't one, so we know it's 0, 0, because I don't have one listed. But then I need one more point. What other point could I come up with? Well, if I do my graph, it'll help me out to show me what other point I can pick. Now again, in Hawks, you are not going to see this graph until you plot 2 points. So I'm at 0, 0. Slope says down 1 and over 1. So that new point is 1, -1, and then your graph will show up. As soon as you put in your second point, your graph will pop into your problem. They'll have this side labeled as A and this side as B. What side gets shaded? A or B? Should I say shade B or shade A? Well, if you don't know, pick your test point, which is 1, 1.
Shade A.
Shade A? Okay. And so if I put 1 in here, -1 times 1 is greater than 1. Is that true or false? -1 times 1 is a -1. Is -1 greater than 1? No. So if it is false, and the 1, 1 is right here, and again, this is divided it into 2 plane pieces, or 2 parts. I got this side of the line, and I have this side of the line. And if it's false, I do not want to shade where it's at, so I want to shade down here. So that's the side that gets shaded with that one. Okay? Alright. Make sense?
Alright. Really good.
Alright, well, let's try your good one.
Alright.
The second here. I get a sheet of paper up here. What was it?
6y plus x is greater than or equal to 6y minus 4.
Okay. Solid or dotted?
solid.
Okay. And now I gotta solve for y so I can graph this thing. So I'm gonna get my y's together. So minus 6y. My y's disappear. What kind of line is that?
Vertical,
Yep, at.
-4.
So it's vertical at a -4. Okay. Two sides to my graph, side A and side B. 2 points. What would my 2 points be? Well,
Greater than, so would it be on the right-hand side, B?
so it would be B, you think?
I would
Okay. How do I know for sure?
put the line.
Put in 0, 0 in there. So if I put 0 is greater than or equal to a -4, is that true or false? True. So I shade where 0, 0 is at. And that would be my answer. Okay.
I'm so confused right now.
Are ya?
Yeah.
Tell you what, let me stop this thing. And I think maybe, how about the rest of you?